All right, how about 2 and 3? You guys okay with those ones?
Yeah.
So use SSS to explain why the triangles in each pair are congruent. So when I walked around and looked, if you said AD is congruent to CB, you should have said given. These two, given. Why is BD congruent to DB in that order? Reflexive property, you should have had that. And then triangle ABD is congruent to triangle CBB by SSS. Okay? Why is MP congruent to MP in number 3? Reflexive property. Okay? Now, did I use the analogy of pinky to pinky yesterday? Okay. So do you see how these ones in 3 are pinky to pinky? The angles and the sides are lined up in order, like that. They're not swapped. Do you see how in number 2, they were swapped? Yes or no? Okay, you could have been able to tell that by either the order of the letters, or, oh look, the single tick mark side meets the double tick mark side in this triangle up at B. In this triangle, they meet together, in this triangle over here, they meet together down at D. Oh, they've swapped. They've swapped places. Can you see it? D in this triangle is B in the other triangle. They've swapped places. Over here, oh look, M and P, M is first, P is last. They're in order. They're lined up nicely, just unfolded like a book. All right. Number 6, you had to plug in 18, get that the angles were congruent, the pairs of sides were congruent, and then use the reflexive property for the second pair of sides. Are these ones pinky to pinky or pinky to palm? Take a minute to look. Who thinks they're lined up pinky to pinky? Who thinks they're swapped pinky to palm? I would agree with you. In this triangle, the 36 is up here. In the blue triangle, the 36 is down here. They're swapped ends. Next. 8 was SSS. Why? Well, 2 sets of congruent sides and then the reflexive property. 10. Do you see how this one's a little different. Do you see the reflexive property here? Not there, down here. It's overlapped in the red and blue triangles. Awesome. How about 12? Plug in 5 and you should have gotten SSS. Any questions for me on the homework? Bless you.
Finally.
Questions on the homework? All right, so we're finishing up for today. All right, did we get to this problem yesterday?
Yes. Yes.
Okay.
It's because we talked about it's 5 and it's 5 and 5. X is 5, so 5, 5, 5.
Oh, yeah, we did.
I thought so.
Sorry.
All right, let's move on to some proofs. All right, so you guys have these ones copied down. The main thing as I'm teaching, okay, a lot of this is me sharing information that I know that you need. All right? I can't say, oh, let's do this one proof. Now that's how you do every single proof. You know how when you solve equations, you see the same patterns over and over and over again? It's similar, but proofs are kind of different. They're each a little different. So I'm going to show you some patterns that you should look for, but I can't tell you how to do every single one. You just have to start to recognize the patterns. So here's the first pattern. When you see parallel lines, which in the given, we're told a pair of segments, 2 pairs of segments are parallel. Okay, well, look up here. Parallel lines. Transversal. Oh, if the lines are parallel, then corresponding angles are congruent. Well, guess what? We're not going to use corresponding angles. Why? Well, look, that's outside of the triangle. You wouldn't ever use corresponding angles to prove triangles are congruent if the angles are outside the triangle, aren't they? Okay, what else do we know about parallel lines? What other kind of angles are congruent? Well, aren't alternate exterior angles congruent? Well, guess what? Not going to use alternate exterior. They're outside the triangle. What about same side interior? They're supplementary, right? But look, this angle is inside the triangle, but this one is like part out, part in. Not going to use same side interior, are we? So if you see parallel lines in a proof, guess which one you're going to use? We said we're not going to use same side interior.
Alternate interior.
Alternate interior. Do you see how those are the ones that are formed by that Z? Remember the Z we have for alternate interior? Those angles are alternating sides of the transversal, and they're on the interior of the parallel lines. If two sets of segments are parallel, alternate interior angles are congruent. Look for that. If you see parallel, you should go straight to alternate interior angles. That's a pair of angles that are congruent. Okay, well, let's see what else we're given here. We're given a pair of sides congruent. Okay, well, our only two choices for triangles being congruent are SSS and SAS. Guess which one this is going to be? SAS. Why? Because there's a pair of angles, and SSS is only 3 pairs of sides, right? So what is the pattern we learned yesterday? When two triangles are joined by a side, we should look for the it's the transversal in the parallel lines, but in the triangles, it's a shared side. It's congruent to itself. Oh, that's the reflexive property. Pinky to pinky or pinky to palm? They're swapped, aren't they? So we're gonna have to be careful when we name them. So we're well on our way to finishing this proof because we have just labeled all 3 parts of information we need. All right, let's go ahead and start writing it down. So always start to make a plan from the picture and then start writing it down. So step 1, BC is parallel to AD. I'm going to go ahead and put the other given. BC is congruent to DA. Those are both given. Now, if I erase what's up here and I start to mark down what I know, the only thing I have marked right now that's congruent is those single tick mark sides, right? So I need to write the result of BC being parallel to AD. If these lines are parallel, then alternate interior angles are congruent. Logan, can you name one of those angles for me? Either this one or that one with 3 letters.
ABC, CB,
Which one do you want to go with?
top one.
CBD? C, B, D. So he went C, B, D. He named this angle right here. Now he chose the order. Could he have said D, B, C? Yeah, he got to choose the order. So the next one that we do, we're going to have to be careful of the order because it has to match that order. I showed you guys yesterday how to name it correctly. Okay, let's call this the green triangle that Logan named the angle in. He named it C, B, D. That's the order he said the letters, correct? So over here, we should name the angle in the blue triangle. Anybody know? Zachary, perfect. A, D, B. A, D, B. Everybody see that, or do you need help? And why are those angles congruent again? Because they're alternate interior angles, and the lines are parallel, so they're congruent. Alternate interior angles. So something I like to do, and I kind of recommend you guys do it as well. Do you know how we're going towards SAS or SSS? As soon as you have a pair of angles or a pair of sides, I start to label them. So do you see how up here in the given, this is a pair of sides? So I put an S and I circle it, that I have a pair of sides. Do you see how in step 2, that was a pair of angles that were congruent? And that reminds me that I have one more piece of information left to write. All right, Grace, are you brave enough to name our reflexive side?
BD and DB.
Perfect. BD congruent to DB, and our reason is the reflexive property. I'm going to label it with 2 tick marks. And that was our last pair of S's. So I'm going to put an S. It kind of lets me know that I've done all S, A, and S. Okay. Are we ready to say that the triangles are congruent? Yes, we have SAS. Triangle. A, B, D. Use the order up here. Just steal it. Is congruent to triangle C, D, B. Reason? Huh? SAS, right? S, A, S. When you get there, you're done. Use proof the triangles are congruent. Not so bad, right? So, things to look for. Parallel lines, you're going to use alternate interior. Shared side, you're going to use reflexive. What about if we see a bow tie or hourglass? Vertical angles, right? Look for those. And there's going to be another one coming up on the next slide. All right, next one. This is one I had you guys copy down in your notes, right? 2 minutes ago? Yeah. Awesome. All right, QP bisects angle RQS. QP bisects angle RQS. Do we want to write the other given on the same line or save it for later?
Same line.
Huh? Same line? Sure. All right, so QR also is congruent to QS. We've set it, so let's label it. QR congruent to QS. I labeled it with a tick mark. Do you remember in the last proof how when we said the lines were parallel, there was a step that came right after it because alternate interior angles are congruent? Is there a result? Is there something that happens when QP bisects angle RQS? Well, first of all, does everyone see where angle RQS is? Is it one of the angles in the triangles? Or is it the whole angle? R, Q, S. It's the whole angle. Do you agree? What happens when you bisect that angle?
Split it.
You split it in half, don't you? And you get two congruent. Let's go back to our cake example. Here's a delicious cake. What can you cut cake in half with? Knife, or a bisector, a sword, a knife, a spatula, maybe a last resort. The nice thing about a spatula is you can cut it and serve it with the same utensil.
That's true.
Save on
That's
dishes.
That's true.
So, are you ready for this? Here's a delicious cake. I just cut it in half. Guess what I got? I got 2 equal pieces of lasagna. No. I got 2 equal pieces of knife. No. 2 equal pieces of cake. Okay? So don't ever say, listen to me carefully, when you're bisecting an angle, don't ever tell me you get 2 congruent segments because of it. That's like cutting a piece of cake in half and getting 2 equal pieces of knife. That doesn't make any sense. You cut the cake in half, you get 2 pieces of cake. You cut an angle in half, you get 2 equal angles. Oh, look. Ready? There's the beautiful yellow piece of cake. You ready to cut it in half? What's our knife? What's its name? QP. Ready? Oh, look. 2 delicious pieces of angle. Okay, careful, they're sharp. Are you with me?
Yes.
Let's name the congruent angles. Angle, blah, blah, blah. It's congruent to angle, blah, blah, blah. What has to be the center letter in both angles? What'd you say? Q.
Yeah.
Q. Q is the center letter. Why? It's the vertex. Who wants to decide the order for us? Nate, thank you. Please name this angle right here, over here, with Q being the center letter.
RQP.
Perfect. Now Nate decided the order. Now we have to follow that order. He went from R to Q, and then down that center side to P. Zachary, what do you think? S, Q, P. Excellent job, Zachary. S to Q, and then down the center side. S, Q, P. Well, what's the reason for those angles being congruent? Well, we cut it in half. When you cut something in half, you get 2 equal angles, don't you? That's the definition of a bisector. Definition of an angle bisector. Well, what's the definition of an angle bisector? A ray, a line, a segment that cuts an angle in half and creates 2 congruent angles. I could have used a knife, I could have used a spatula, I could have used a sword. Those are the things that we're bisecting the angle. The angle has been bisected. It's 2 equal parts. Are you with me? So stock that into your little bank of information to use on proofs. If you see the word bisector, you're going to have 2 equal parts of something. What happens if you bisect an angle? You have 2 equal angles. Can you bisect a side? Ready? Here's a side, a segment. Can you bisect a side? Yeah, you get 2 congruent segments, sides, right? Oh, look, maybe this is in some sort of triangle like that. I don't know. And then you could use that in the proof. You see how that could be used? You see the word bisector? Next line, 2 congruent things depending on what you bisected. Maybe you bisect a donut and you get 2 congruent Donuts.
That sounds good.
Peace, love, and little donuts. All right, so what do we have so far? Up in step 1, we had a pair of S's. Step 2 gave us a pair of A's. Are we there yet? Are we there yet? Are we there yet? No. Let's keep going. Pair of S's, pair of A's. Tristan, why do you think, what other pair of S's are going to be congruent?
SP or bottom part SP and RP.
Do you have a reason for that?
No, I do not.
We have to have a reason, bless you. Now, what about the shared side right here? When we see a shared side, which property do we think of?
Reflexive.
Very good. Can you name those for me?
QP
Yep.
is congruent to QP since they're side by side.
Ooh, very nice. QP, convert to QP. And they were pinky to pinky, weren't they?
Mhm.
Do you guys understand what I'm saying when I say that?
Yeah.
Makes sense? Okay. And you said it's the reflexive property. Oh, that's our last pair of S's that we needed, isn't it? Are we ready to say that the triangles are congruent? Yeah. Triangle RQP is congruent to triangle SQP. With a little sass. SAS. Does that make sense? Okay, so here's the deal. You're gonna see this picture again. You're gonna see, I can only give you so many types of proofs, all right? You're gonna see all of them by the time we're done with the chapter. If you see the word bisect, do you know how many times I have people tell me this? Oh, bisect angle RQS. Oh, okay, RQ is congruent to SQ, definition of a bisector. No, you didn't cut any segments in half. You cut an angle in half. Or people will say RP is congruent to SP, definition of a bisector. No, you didn't. It doesn't say anything about cutting that in half. What'd you cut in half? The angle. 2 equal angles, name them, right? Okay. Next thing you should look for, I told you about vertical angles when you have an hourglass, point-to-point triangles. Another thing you might see let's test your memory from earlier this year. What if in the given it says B is the midpoint of AC? B is the midpoint of AC, given. What's the next step?
B is congruent to BC or CE,
Reason.
definition of midpoint.
High five from a distance. Well done. Isn't that what a midpoint is? It's the definition. It creates, if it's right in the middle, the segments on either side of it have to be the same, right? Oh, I just ran a mile, but I stopped halfway. Oh, you stopped halfway? How far did you go? Half a mile. A half a mile on either side. How far I've gone and how far I have left to go. That's the definition of being in the middle of the mile, right? There you go. You're gonna use that sometime. Wink, wink. All right, so our homework tonight is in red. It's 13, 14 through 18, and numbers 1 and 2 on the worksheet. What worksheet? I'm glad you asked. I'll go ahead and pass it out.